Good morning, everyone. My name is Specialist Acosta. Today I will be conducting a unclassified training on how to convert azimuths. Our task for today is to convert an azimuth. Our conditions are you're a member of a squad preparing to conduct tactical movement and you have been directed to convert azimuths in preparation for the movement. You have been given a 1/50,000 military map with a declination diagram, pencil, paper, a magnetic azimuth, and a grid azimuth. Some iterations of this task should be performed in Mach 4. However, we do not have that today. Our standard is to convert an azimuth into a back azimuth, a magnetic azimuth to a grid azimuth, and a grid azimuth to a magnetic azimuth. The risk assessment for today's training is overall low, but please be mindful of the wildlife and our environment. There are plenty of potholes around, there are plenty of squirrels running, so just leave them alone. Don't touch them. You guys came into this area where it's cleaned. Please make sure that when we're done with the training today, you leave it as that. The weather is kind of dry and the sun's going down, but please be mindful to stay hydrated at all times. Also, if you guys have any garbage, please don't leave any behind. All right, let's begin our class. So, I will start out by passing out maps, some pencils, some paper, and then we will get into our training. Protractors, maps, and pencils and paper are also over here if I forgot any of you guys, so just make sure you come up here and get one. Did everyone get one? Okay, cool. So, moving forward, I'll be demonstrating how to convert the different types of azimuths. Watch this demonstration. Alright soldiers, I have just converted azimuths. I converted an azimuth into a back azimuth, a magnetic azimuth to a grid azimuth, and a grid azimuth to a magnetic azimuth using a 100-degree angle. So, you guys might be wondering, how exactly did I do this, right? You saw what I did, but now you want to know how I did it. One of the most important tools we have when we use a map is our declination diagram. Our declination diagram is always found at the bottom right of a map. Also be mindful that when you're reading a map, you're always reading a map right and up. And that's how our declination diagram looks. This is a model of our declination diagram. As you can see, grid north is going upward. Grid north is always going to go upward. Further on this will be the north-south lines designate grid north on your map. The compass needle points to magnetic north, and the grid magnetic, the GM angle, that's what we're going to be referring to a lot today, is the angle difference between the grid north and the magnetic north. Also, everyone, when you guys are converting azimuths, please be mindful. There's a warning. You have to be aware of how you're converting an azimuth, because you don't want to add 180 degrees to, let's say, converting a grid azimuth to a magnetic azimuth, or vice versa. You have to make sure you're doing it correctly. So the warning is there. A simple mathematical mistake could have disastrous consequences. You'll end up on like the other side of the Fort Rucker in that case if you were doing it incorrectly. So now I'm going to show you exactly what I did on my paper. To convert an azimuth into a back azimuth, we're going to be using, just a given number, 170 degrees. So, 170 degrees. When you're thinking about 170 degrees, you have to be mindful. Is 170 degrees less than or more than 180 degrees? Well, 170 degrees is less than 180 degrees. Since it's less than 180 degrees, you are supposed to add 180 degrees to find your back azimuth. When you're finding your back azimuth, it's from the point, let's say you found a point on Rucker, the coffee zone for example, on your map. What you're going to do is, okay, my point is 170 degrees from here. So if it's 170 degrees from here, now I'm at that point. Now I have to find my way back. I have to add 180 degrees to that. 180 degrees to that will be 350. So now your back azimuth is 350. On your way there, it was 170, but now you're coming back. It's going to be 350. Now we will be converting a magnetic azimuth to a grid azimuth. Magnetic azimuth to grid azimuth. In order to do that, you have to use your declination diagram. All declination diagrams are different on each map. So just because we're using this declination diagram today does not mean you'll be using the same one for a map at a different installation or a map in a different location. So for our declination diagram, we see there is a westerly side and an easterly side. So when you're looking at your map, you're going to be looking at it, this way, not necessarily the way I'm showing you on camera. Westerly will be on your left. However, on the paper, it'll be on the right. So paper's on the right if it's, facing me, left if you're facing the paper. You have to determine whether magnetic north is on the west side or on the left or on the east side. On this diagram, it's on the east side. However, on my map, it's on the west side. So I've determined that on my map, magnetic north is on the westerly side. Next, I have to determine what the GM angle is. Remember, I said the GM angle is the grid magnetic angle. For this particular map, it is 3 degrees. So to convert a magnetic azimuth to a grid azimuth, subtract GM angle. You will also find that information on your declination diagram. It tells you what you're supposed to do. If you're converting from a magnetic to a grid, you will subtract. If you're converting from a grid to a magnetic, you will add. In this case, we will begin with subtracting 3 degrees from, what was the number? Let's say the number is 148. So our number is 148. If you guys want to write this down, you can. If you can do math in your head, go for it. So 148 degrees minus 3 degrees, because 3 degrees is our GM angle. It equals 145 degrees. And that's all it takes. That is your magnetic azimuth to a grid azimuth. Next, we will be doing conversion of grid azimuth back to a magnetic azimuth. So for that one, the number I'm giving you is 21 degrees. Okay, so again, look at your declination diagram, right? Here it says 9.5, but the one we're using still, again, is 3 degrees. So if it's 3 degrees, and at the bottom of your map it says to convert a grid azimuth to a magnetic azimuth, add GM angle. So what are we doing this time? We are adding the GM angle, not subtracting. Don't confuse the two, it's adding. So we're gonna be adding 21 degrees plus 3 degrees. That is 24 degrees. And that's your magnetic azimuth. You have just converted it. Again, every GM angle is different on every map. In this case, it was just 3 degrees. However, for other maps, it could be 50, it could be 9.5, it could be something different all the time. So, now that I have demonstrated and explained how to convert azimuths, soldiers, it is now your turn to convert azimuths. After this training session, there will be an assessment to see how well you understood the material. I will be giving you 10 minutes to work on this with your battle buddies. Look to them for help before you want to ask me. Of course, you are free to ask me any questions you like. Don't be afraid. But let's see if your battle buddies also retain some of this information. I will be giving you guys your angles for your azimuth, so please have a pen or pencil ready and your paper. So let's see. Are you missing a protractor? Okay. Oh, he's gonna let you use his? All right, cool. So, is everyone ready to write these numbers down? Okay. So for your azimuth, the one that you will be starting with to find your back azimuth, it's going to be 127 degrees. You will convert this azimuth into a back azimuth. Next, you will use the same azimuth to convert a magnetic azimuth to a grid azimuth. You will use 76 degrees to convert your grid azimuth to a magnetic azimuth. So remember those numbers, 127 and 76. You have 10 minutes and your time starts now. Alright, so you see how I said earlier, you have to be careful when you're converting your back azimuth to not confuse the two when you're adding 180 degrees and subtracting 180 degrees. Alright, so my warning was again, let me see, you should be careful about it. Just don't convert a back azimuth to incorrectly by adding or subtracting 180 degrees. Make sure the number is either under 180 or over 180. You got it? All right. Everyone remember, if your number is under 180, what are you gonna do? Add 180. If your number is over 180, what are you gonna do? Subtract 180. Alright, soldiers, please stop what you're doing. Put your pens, pencils, and papers down. Can anyone tell me what they got for a back azimuth? Anyone? Okay. What you should have got is 307. The way we got that was, well, our given angle was 127 degrees. And if you remember, I was saying if it's less than 180, you have to what? Add 180. So we added 180 to 127, and that resulted at 307 degrees. That was our back azimuth. Next, we used the same 127 degrees, and we had to look at our declination diagram. Remember, it's at the bottom right of your map. And what does it say? The GM angle is 3 degrees. So to convert a magnetic azimuth to a grid azimuth, you have to subtract what? 3 degrees. So 127 minus 3, can anybody tell me? 124 degrees. Good job. It's grid azimuth. All right, next I gave you another angle for your magnetic azimuth. So this is going from grid to magnetic. That was 76 degrees. Revert back to your declination diagram, right? Declination diagram. And what does it say? 3 degrees is your GM angle. So for this one, to convert a grid azimuth to a magnetic azimuth, add your GM angle. So you will be adding 3 degrees to 76 degrees. What is that? 79 degrees. Okay, class, you guys got it. So now I will be assessing you to see if you really understood the material. So we won't have a review like this after that. You guys are just gonna give me your papers back and I will review to see if you guys understood it or not. So I will give you another 10 minutes to assess your abilities and see how well you understood this material today. All right. Your time starts now. Oh, I almost forgot, y'all. My bad. Your degrees are 196 degrees for your back azimuth, and you are using as well then 196 degrees for your grid to magnetic, and for your magnetic to grid, it's going to be 40 degrees. My bad. Soldiers, the time is now over. Please stop what you're doing so I can record your results. I have recorded all the results from this training. There are no retrains or ready tests today. You guys all did very good. This training is now complete. Please return all your maps, all your pens, all your pencils, papers, anything you guys took from me, you guys better return to me. Please police call after yourselves. Pick up any garbage, any plastic water bottles you guys left behind. We don't want to mess up our environment, y'all, so please pick up after yourselves. Does anyone have any questions about the training today? No questions? All right. We'll now be conducting our AAR. So, what was supposed to happen today? Well, today we were supposed to convert azimuths. Did we do that? Of course we did. We converted different types of azimuth, 3 different kinds. Back azimuth, grid azimuth to magnetic azimuth to grid azimuth. Do we have any sustainments? Okay. Do we have any improvements? All right, so some sustainments are to keep conducting these trainings to maintain knowledge on the subject. I agree, because a lot of us forget about this stuff. Improvements. You want me to use more examples, give you more numbers? Okay, I'll do that. All right, soldiers, you all tested proficiently in today's training. Congratulations. The training is complete. Sergeant, we have 10 trained, 10 proficient, and 0 trained. This concludes our training for today. You are all dismissed.